This this conference will now be recorded.
Hey, once again, good morning, good evening, guys. This is Satish from Isha Training Solutions. I'm quick introduction about me. I've been with Isha for the training for the last 2+ years, and I have a total experience of around 14 to 15 from performance testing and then to performance engineering and then into the product development. So total of 14 to 15 years of experience is what I have. And today, what we'll look into it is the course content, right? For this batch, for the performance engineering, what are all various topics we are going to learn? I'll go over the topics one by one, but at a high level, so that you'll get to know what exactly you're going to learn in the next 3 to 4 weeks. Okay. So before that, I assume that most of you are from the performance testing background or probably other testings or maybe a development, right? So as a performance tester, right, what you do today when you go for the interview or as part of your project, you will be doing all these things which I have listed on the left, right? So you might be doing the scripting and execution, and you might be doing a monitoring a bit, or may not be doing a monitoring, where a separate team might be doing those monitoring and use these stats, and you might be providing your tool-based report either from Jmeter or LoadRunner, and you might use the APM tools like AppD or to provide the high-level analysis. And for your project, for your application, there will be a separate engineering team who will be there for any bottleneck analysis, or your development team might be involved directly. Right? So the work, whatever you do, will be purely on the uh, requirement and the scripting, execution, little bit of monitoring, and providing the report for every test. Okay, but when it comes to performance engineering, um, the kind of work or the scope of work is going to extend out of this. It's not a separate track. Earlier, there used to be a separate engineering team and testing teams for carrying out these work separately. But now, in the project where people are expected to do development and testing together, we cannot expect a dedicated team for testing and engineering. There is no way it is going to happen, right? So the engineering is going to be an extension of your testing, one that will make you more um, relevant in the project, more applicable in the entire SDLC cycle, right? As a tester, you might be getting involved only in a certain phase of your development life cycle, right? Maybe if it is a 1 year program, you might be involved in 2 months or 3 months, maybe from August to November or September to December, right? Whereas when it comes to performance engineering, your presence is going to get extended, right? You might get involved from March or April till December. So relevant, your presence is going to be required more, and you're going to be more relevant for the project. Okay. So in that aspect, what are the various things that you do from engineering? Um, One is going to be your server-side profiling. So when you go to the interview or when you part of the project, you should be able to confidently say, I know server-side profiling, I know client-side profiling. I'm good at taking the dumps, analyzing the heap dumps, thread dumps. I can analyze AWR reports. I know to use the tools like JProfiler, JVisualVM, JConsole tools for monitoring and analysis. I know to benchmark and tune JVM. I know to monitor the garbage collection. I know how to analyze the garbage collection logs, and I will be able to use efficiently the APM tools to do the deep dive diagnostics. and I know how to use both open source and commercial tools when it comes to monitoring. All these things will be your scope, and you will also be able to go and carry out these things in your project efficiently once you learn the performance engineering. And the objective of this course as well to provide you these list of topics, get you trained in those area, um, so that at least to a certain level you can go and start working in a project, or at least see, most of the time what will happen is in a project where if you're experienced engineers, you will be getting these work, right? If you're not experienced enough, either you might not be willing to take this work, or they will not assign you. It is kind of a cat and mouse. You don't know, you will not be able to work until you work. You will not be able to um, learn these things. So what this course will give you is the head start, right? By attending these sessions and then doing a hands-on on all these things with a actual application in your laptop, you can confidently go and say, I haven't got a chance to work on the um, any engineering project so far, but I have done my homework. I have learned all these tools. I've done the hands-on in all these areas. I know how to do it, and I'll be able to extend that in the work as well. And even in the interview, right? When you're going to be competing with performance testers who knows only testing, and you're going to go and say, I'm good at the performance testing, and I also know all these things. I don't have an working experience, but I've done all these things on my own. Then definitely you can easily edge out the other folks, right? That is what very sure. Even if I'm taking interview or you're taking interview, if there are two people who knows only testing and plus who knows the testing plus um, engineering, though they don't have experience, if they can confidently say that they have learned out of their passion, nobody will be hesitating to take these people. So the importance of engineering is going to be more and more relevant in this current scenario, and it is an extension of testing as well. Okay. So I'll go through the topics and then come back to this SDLC cycle, how this is going to fit into the your various phase of your development life cycle. Okay. Just give me 1 second. I'll take some water. Okay, so to get started with this, right, before we get into the performance engineering topics, we'll spend some time on the basics. When I say basics, one is on the programming language, the Java basics, because throughout our course, we're going to talk about the heap or threads, CPU, um, or the garbage collections, right? All these things is what you're going to do it during the profiling or monitoring or analysis. So it's very important for you to know um, what is heap, what is stack, what is the JVM, what are the internals of JVM. Normally, right, when you go and talk to the developers and tell that a transaction is having high response time, we will have a lot of challenges, right? That they might not accept it. They will put blame on your script or test data or environment. It's not easy to go and convince the developer saying your transactions are having high response time. Now, if you're going to go one step ahead and they're going to go and say your code is having a problem, your object is having a leak, or if your method is going to have high response time, then it's going to be even more difficult if you're not comfortable with these terminologies. They can easily uh, convince you, or they can easily distract you with a lot of other jargons. So it's very important for you to get comfortable with all these terminologies, and also to know how exactly these methods are created, how the classes are created, how the objects are created, what happens inside the JVM, how a war file is created, how a jar is created, how it is deployed. So we are not going to go in depth, we are not going to become a developer, but it is going to be important to break into that area, and at least to a certain level, it should not be a black box. That is what we'll try to do it in the Java and Jvm Basics. We'll go over a few programs, how to create those programs practically. Okay. Um, and then once we are little comfortable with the terminologies and how these programs are created and deployed, then we will start with the engineering topics. Okay. Um, from the, as I said, right, as a performance engineer, you get involved in the very early in the life cycle. When a development starts, when a developer is going to deliver a particular page or particular functionality, a particular API, particular service, you will get involved to make sure that at a component level, at a service level, whether your performance are optimized. Okay, so we will assume that we are in a project where a fresh development is started, and then we are going to get involved early. What are the very things we are going to do it? So one is going to be a response time analysis. You either call it as a, server side profiling or your CPU profiling. The intention is for a service, for a API, for a web page, for a functionality, how much time it takes as an end user, and all the way from the UI to the server to the code, how to get your response time, and if the response time is high, how to profile it, and then get into the code level to say, okay, the response time is high at this class, at this method, right? And in terms of queries, if there are queries getting executed, what is the query level response time? So for a single user, response time analysis is what we will get started as part of the our first session into the engineering. Okay, so we will use a combination of tools like a JProfiler, Tomcat Access Logs, Chrome developer tools. All these combinations we will use it in order to do this analysis. Okay. And guys, are you able to hear me? Can you please give a confirmation on this?
Yeah, we can hear
Yes,
you.
we can hear you.
Okay. Yeah, thank you. And if you have any questions, feel free to put it in the chat. And once I go over complete all these things, I can take those questions as well, or you can unmute and provide your questions later as well. Both you can. Okay, fine. So
Yeah.
for yeah, thanks. For the same functionality, for the same API or the service, once you do the response time analysis, response time optimization, it is very important to analyze the memory consumption as well. Okay, see, for every service, um, uh, the way it is going to consume response time, the way it is going to consume the heap, it is going to determine the capacity of your JVM or your server, right? End of the day, how much time it takes is going to be directly proportional to CPU consumption. More time it takes, more CPU time it's going to take, and and more memory it is going to occupy. Say your heap. I'm going to talk about heap and all these things in the later. But anyway, at a high level, right? If your heap is going to be 4 GB, and if a particular login is going to take say 100 MB or 200 MB, more it takes, more it is going to consume the a percentage of your overall memory. Okay, so when you're going to optimize this heap, optimize your response time at a level, at a functional level, it is going to have a very good positive impact on your capacity of your JVM later. When you have to run a load test for 1,000 users or 1,200 users, if a JVM handling 800 users versus 1,200 users, it all depends upon how much CPU each of your service is going to consume, how much memory is going to consume. The more you optimize, more is going to be your capacity. Okay, so and those things as well is what you will do it as part of your performance engineering. As a single user server side profiling, you will try to analyze for each of these functionalities. Okay, So as part of this, we'll try to understand what is Java heap, what is stack, what is the relationship between heap and stack. We'll go and do this heap analysis, leak analysis, and then we'll also get into the so this leak analysis or server-side profiling for memory is at a single user level, right? But when it is going to happen at the load test, you do a load test, you do endurance test. That point of time, if you want to analyze your memory, if your memory pattern is bad, if you want to analyze the memory, then you cannot do the profiling, right? You have to take the dumps. Either to analyze the memory, you take heap dump. To analyze your threads, if the CPU is high, if the response time is high, if you want to analyze the threads, you go and take a thread dump. So heap dump analysis, garbage collection analysis, and then thread dump analysis, all these things will be looking into it one by one. Also, from a thread perspective, we'll try to understand how threads are created, what are the various states of thread, thread contentions, how to configure the threads, and I forgot to tell about the heap, right? From a heap perspective also, how do you go and configure your minimum heap, maximum heap, your garbage collection tuning parameters, what are the various tuning parameter will use it for garbage collection, what are the various collectors, what happens inside GC. So all these things are going to be a comprehensive session on each of these topics. Okay. And all these things are pretty much on the server side, right? Heap dump, thread dump, GCs, thread contentions, Java heap, stack, everything is on the server side. And when it comes to your end user experience, though you're going to analyze, fine tune your server side, it's very important for you to optimize your client side as well, right? Because that is what your user is going to experience. User is going to visualize it in this browser. So we'll go over the client side analysis from a testing perspective, from the engineering and the optimization perspective. We'll go over the client side analysis. As part of the performance testing, right, you might have created test plan or test strategy. Similar to that, you have to create a monitoring strategy as well. See, end of the day, you do a lot of scripting and you do a lot of execution. Until otherwise, you will be able to go and look into each of this component and understand what is happening there with respect to CPU or memory or thread. You should have a complete visibility. They call it as observability, right? You should have a complete visibility on every component in your architecture. So as an engineer, you should be able to go and analyze your architecture and then look into various components and then create a monitoring strategy. You should go out to your production support team or your architects, your server team to know for each components what is their strategy for production monitoring. Definitely, they might have considered certain tools for using it in the production. You have to extend that for your performance testing as well. Okay, it is that you need to go and ask it and get it. Otherwise, it's not their responsibility to take care of these things. They have to give the tool access, but it is something you need to draft the strategy saying we are having 10 components in your architecture. We are going to do a load testing, endurance testing, and I need access to these tools so that I will be able to monitor and then provide the analysis. Okay, so once you have this strategy, then you will clearly know what to monitor and how to monitor. And from a monitoring, in this session, we'll try to learn the AppDynamics from a configuration perspective, how to set up the SaaS AppDynamics, how to configure a Java application, and then how are we going to monitor it, how are we going to use it for diagnostics, response time diagnostics, to troubleshoot a response time problem. So we'll use AppDynamics for the AppDynamics SaaS version for the learning. And from a open source monitoring perspective, we'll also try to learn the one of the famous infra level monitoring, tick stack, telegraph, inflex, grafana combination. The reason is most of the enterprise applications, critical applications, they will have the APM tools for sure, Dynatrace or New Relic or AppDynamics, but around 30 to 40% of the applications might not be critical due to cost factor. They might not have these APM tool. Bare minimum, we should be able to at least get the infra level statistic during a load test, what is your CPU consumption, memory consumption, your disk utilization. So for that, we generally go and use the Windows Perfmon or Linux vmstat, iostats, top commands to get it. Or we rely on the other teams to provide us the data. But with TickStack or Telegraph and InfluxDB, you can yourself go and easily configure it, and then you can create dashboards through which you can easily monitor those statistics. So we'll try to learn how to configure it, how to install it, how to create dashboards, how to monitor it. Okay, so we'll go and run few load test, a small volume load test to troubleshoot the response time problem with AppDynamics. We'll discuss about the latency issues. But I have a sample application. It's not a sample application. It's a Java application. Let me open you that. So the way we will learn these topics are, right. We will go and build the code. Okay, let me go and show you the. Let it open. So I have a Tomcat in which I have the war file deployed for e-library application. Is already I already started before the session. Okay, and let me open the app as well. Yeah, I think it gives you JDBC exception. See, again, from a performance engineering, right? You might get a dedicated system for you where you will install the app, you will install it in the Tomcat, and you will have your own profiling environment or engineering environment, right? So you should also be comfortable enough to, if there's something is not working. For example, now login gave me a blank page. Now instead of me going to developer and saying login is not working, I can still go and check my log. It says that there is a communication link failure, right? So these things you should be hands-on, right? By practice, you can become a hands-on. We cannot rely on the other teams to do the setup for you. That's what expected as well. So you might have your own Tomcat or JBoss or WebLogic server in which you'll go and install your application and you'll start it. Okay, and in this case, database might be down, so you may have to reach out to the database team or developer saying the database connection is not there, or it is not able to establish the database connection. Turn on the database. So instead of just saying login is not working, you should be a little more particular or technical about what I want to communicate, right? That's all going to increase your confidence in the project. I'll go and start it. Now let me go and try the login. It is still starting actually. Okay, let it continue. I'll finish the topics what we will cover it. So from the application side, right, then we will move on to the database architecture. We'll try to learn the Oracle database architecture, how it is designed, and as an application performance engineer, so you're not going to be a database performance engineer, right? It's a separate stream. We as application performance engineer, we will try to learn from that perspective how to analyze the database, how to take these snapshots, how to configure the AWS reports, and how to analyze the AWS reports. The database DBAs and the DB performance engineer are going to do a lot more when it comes to tuning, or when it comes to configuration of your memory. Lot of aspect we will not be able to get into that area at all. It's a very niche area where DBAs will control it, right? But from an application perspective, we will try to learn how to look into the AWS report, how to analyze your database calls, how to analyze the database performance. Okay, and then at the last, after learning all these things, then we will try to learn the concept about what is a non-functional requirement. Now we write an engineering strategy, right? So ideally, this engineering strategy or non-functional requirements we used to have it at the beginning, but without knowing, without understanding all these activity, right? It is very theoretical when it comes to the strategy of engineering. So at the end, we will try to go and see how we are going to analyze the non-functional requirements, how to draft your engineering strategy. Apart from that, right, though you learn engineering, all these topics, but wherever you go in the project or in the interview, people talk about these modern stuff, right? Like DevOps, like cloud, like synthetic monitoring, like resiliency, like chaos. Though we might do it, we might not do it, but the topic is very, very interesting. And wherever I go, the people might ask you whether you've done something on the Jenkins integration, what you've done with respect to the pipeline execution, whether you've done cloud project, what is resiliency, what is auto scaling. So we'll try to have as part of the future readiness, we'll look into the introduction to DevOps. We will try to understand how in a project the DevOps is handled for performance testing. We'll also try to learn Jenkins and Jmeter integration. And then we'll also learn synthetic monitoring, which is a production monitoring using Dynatrace. We'll try to create scripts and configure the scripts to do a synthetic monitoring. And then from a cloud, we'll try to understand what are additional scenarios you may have to consider, because in a lot of places people think that cloud will take care of the performance. Why do we need a performance testing at all, right? What is the myth around it? What are additional scenarios you need to consider? What is auto scaling? What is resiliency? What is chaos testing? All these things we'll try to understand, learn from an introduction to cloud. And as part of the bonus topics, right, you will be getting the 8 hours of Linux videos and 6 hours of Selenium performance automation, or from Selenium, how to get performance metrics through a Selenium script, right? So these things you'll get it as an additional videos which you can refer offline, right? Again, this is in terms of to make you ready, or make you aware of how to do a monitoring, or how to use Linux for performance testing, because we handle a lot of things using Linux server, right? Your Jmeter machines can be a Linux server, your app servers can be your Linux servers. So you should be able to know how to monitor what all commands you will be using it, what are the way you will set up your Linux machines for your load generators. So all these things you will be getting it from this particular topic. Okay, so yeah, these are the things which you will cover it the next 3 to 4 weeks. And let me see if the server is up. Okay, so this is the SaaS version of AppDynamics, which I'm using it, which we'll also use it for our learning, right? We will set up the separate SaaS version, how to set up, how to connect this. So the Tomcat is running in my machine. This e-library application is running in my machine, right? This is a local host. And the data of this e-library is getting monitored using the AppDynamics, right? For instance, if I want to know the errors, right? Just an example, because I was getting JDBC connection issue, right? So if you go into these errors, we'll try to learn, monitor all these things probably during the AppDynamics sessions. But just want to show you, right, from a HTTP error code perspective, null pointer exception, 404, 500, you'll also be able to troubleshoot these problems. If you have AppDynamics already available, you'll also be able to go and look into those, the reason for your failures and the response time and your all the business transaction response time, your database calls, your remote services. Again, I'll not go to since it was opened. I was going into this, but AppDynamics will be a separate section. Again, if you haven't used the APM tool at all, most of these tools are commercial tools, right? But AppDynamics and Dynatrace provides you some trial licenses in the SaaS through which you can play around. So all you need is right. Let me see. Yeah, I think the login is completed. So this is the application which we will be using it for our profiling, for our analysis, for your running some load test. All these things we'll be using this application, and I will provide you this WAR file and the Tomcat configuration, which you can actually. I'll provide you this WAR file, which you can actually set up in your own machine. Right. What we need from you is a laptop, a Java, Eclipse is optional, Tomcat, and the WAR file, which I'm going to give it to you, and the few tools. All tools are going to be nothing. You're going to get it commercially. You're not going to buy anything. Everything is going to be either open source or a trial licenses. For you to practice everything, whatever I teach, you will be able to practice it after the session or in the weekend or after the batch, right? Everything will be able to do it by yourself. There's nothing like I have my tool license, I'm doing it, you cannot do it. Everything what I do it, you will be able to do it. Minimum thing what you would need is a laptop, a Java, and a Tomcat. And I'll provide you the WAR and all the details, all the softwares and list of things that needs to be get installed, right? That is going to be part of the I'll go to the drive. You will get an access to the Google Drive, where you will get all these softwares, all the documents, all the artifacts, all the documents that we create during our profiling or analysis. Everything is going to be part of this drive. So once you register, you'll be getting access to this drive, and in the softwares sheet, you will get the list of software that you need to install. The link from where you need to download. Either you can download from the drive as well. For example, right, for memory leak, if you go to the memory leak, the WAR file that will have a memory issue, and some of the sample EEP reports, the Java code. If you are planning to set up the code as well, right, I can also provide you the way you can set up your code in your machine. It's not mandatory. If in case, for example, this is Eclipse project what I have, and this is the e-library project. In the project, I'll be modifying the code to the transactions. Say all these things are add book, issue book, log out, delete librarian, admin login, add librarian. All these things are all functionalities of your e-library. So I might be going and changing few things, so which can provide you the response time problem, which can create a memory problem. So either you can set up this project in your machine itself, so that you can also play around with the code, but it's optional. I will anyway provide you the WAR file for every topic. For memory leak, I'll provide you the WAR file, which you just need to download and then go to the Tomcat and go to the web apps and copy it. It's not going to be difficult at all, right? It's nothing is difficult in fact, because once you know how to do it, once you start doing it, it is not a rocket science at all, right? It's very tool driven. All the things you're going to get out of the tools, you just need to get that experience, get that hands-on at least for once. Nothing is going to be difficult at all. So Eclipse, don't worry, if you're not comfortable with Java or Eclipse, it's not mandatory, but Tomcat is mandatory. So all you need to do is have a laptop, have a latest Java, Tomcat, and the code which I'm going to give it or what I'm going to give it, and the few tools. Okay, and throughout the session, we are going to deploy the WAR files, test it, identify the performance problem, and do the profiling diagnostic, do diagnosis, and then we are going to provide the recommendations. And we'll go and look into the code as well, how which part of the code is having a problem and why it is having a problem. Okay, so that's how we are going to learn most of these topics in a practical way. Okay, these sessions are going to be between the same time like today, 8:30 to 9:30 p.m. IST. Yeah, if you have any questions, guys, I'll stop it here. You can either put it in the chat or you can feel free to ask. Okay, there are a few questions. Is there any training on Dynatrace? Okay, so there are many APM tools. Okay, you have AppDynamics, Neuralink, you have Dynatrace, right? It is not going to be easy to go and learn everything at the beginning. Maybe with the experience, you might use it in certain project. But conceptually, every APM tool is going to do the same thing. From APM tool, you have to you will be able to get all these server-side metrics, your heap, your GC, your thread utilizations, your server-level statistics like CPU, memory, thread utilization, or disk utilization from application metrics. And then if the response time is high, diagnosing the application response time problem, database calls, third-party calls, all these things is what you will be able to monitor it. And APM tools, any APM tool is going to do the job. So if you can learn at least one APM tool, that is going to be more than enough. API testing or API engineering is not going to be different. I'll tell you what we're going to do it for API as well, but it's not going to be different at all, right? From a server-side analysis, be it is a profiling, be it is a heap dumps, be it is a load test, or analyzing your garbage collections, your APIs or your web app is not going to be any different at all. I'll cover it when we are going to do these sessions. Do we have a lab where we can practice? No, there is no lab, because all these things are something you can install it on your own. See, when you go to engineering, performance engineering, right? You have to be comfortable with installing these tools. You have to be comfortable to configure it, right? So, and it is not going to be, if you want to install Performance Center, or if you want to install the AppDynamics, every component of AppDynamics, then it's going to be a very tough job. But all the tools, whatever you're going to use it, is something very straightforward, which is not going to be complicated at all. So you can easily set up in your laptop, and that's the reason we don't have any lab, and there's no need for lab for two reasons. One, we want people to install the tools and get the hands-on, right? Because when you install, you will end up with some problem and you will troubleshoot it and you will learn it. And second, all these things are all very, very self-explanatory tools from an installation perspective. Only AppDynamics is complicated, but that too, we are using a SaaS version. So you're going to do only the configuration, you're not going to do installation or setup. Even in the project, you will not be taking care of the installation. That's a very, very complicated procedure to do installation and configuration. Most of the time, it will be done by your AppDynamics admins or Dynatrace admins. Okay, how this training helps Python-based applications? Okay, see, your application is going to have multiple technologies, multiple programming language, right? It can have a Java layer, it can have a .NET layer, it can have a Node.js, it can have a Python, and end of the day, every component is going to consume CPU, everything is going to consume memory. So basics are going to be same. And obviously, in 25 days or 25 hours of session, you cannot go and cover everything. That will be a really, really overwhelming, and it won't be focused as well, right? The reason why we picked Java is any enterprise applications, you're going to have a Java layer for sure. And even today, Java has been widely used in most of the enterprise applications. And in the interviews, you're going to get a question around the JVMs, your JVM concepts, your Java benchmarking, Java profiling, tuning parameters. Okay, so for multiple reasons, Java is a good place to start. We are already a performance engineer, where you already know all these things. then you can probably try to expand your knowledge. If you are working in a Python project, or if you're working in a uh, um, Node.js project, there you can probably try to extend this knowledge. As I said, end of the day, everything is going to be CPU, everything is going to consume memory, uh, everything has to be monitored. So you want to apply these concepts, but every Node.js or Python is going to have their own libraries, tools to monitor and track the conceptions. So yes, so this batch, which is going to be running for 3 to 4 weeks, is going to focus on the Java, and that will help you to extend it to other languages or other platforms as well. Do you have SaaS version of Dynatrace? See, yes, you can go and register the Dynatrace with your Gmail ID. I think they give a 2 weeks of SaaS version. We don't give you the SaaS version. You can use one. Go to dynatrace.com. You can go and register with your Gmail, and you can set up your own Dynatrace. For AppDynamics, I will tell you how to configure the AppDynamics with your e-library application. And you can do the same thing so that you can learn all the aspect of AppDynamics or APM tool. For Dynatrace, the one thing which I will cover is the synthetic monitoring. Okay, in using Dynatrace, how to configure the synthetic monitoring scripts, how to run it, how to monitor it, that I will cover it when it comes to the synthetic monitoring. But if you wanted to configure and use it for your application performance monitoring, you can still do it. The SaaS version, you can get it easily using your Gmail ID, and then if you have a local application, you can try to configure it. Yeah, you can easily set up your SaaS version. So the apps are built using containers and deployed in cloud platform. So okay, see, apps are not built using containers. Okay, it is deployed in containers. The application is going to be the same. It's not going to any different at all. Instead of installing it and deploying it in the your physical machine directly, they are going to create containers, and inside the containers they are going to deploy it. So those are just the carriers or infrastructure layers. From application performance engineering, it's not going to, there's nothing going to change at all, right? All your client side profiling, server side profiling, heap dump, thread dump, GCs, AWS report, everything is going to stay same, irrespective of the application is going to get hosted in the on-prem or it is going to be there in the cloud. The monitoring might differ because when you're going to install it in the container, you may have to do a container level monitoring. For that, if it is AWS, you might use CloudWatch. If it is Azure, you might use Azure Monitor. Right? All these things are all specifics. What we're talking about from a performance engineering perspective, it is not going to be any different at all. Okay, because application is application. You deploy it in a mission like my mission. I have a Tomcat here where I have deployed the war. If I want to have a Docker container in my laptop, I'll deploy it inside the container. There is a the reason for containerization is it is easy to package it. It is easy to maintain the dependencies. If you're going to install a tool, install your application in a new VM, right? You have to take care of multiple things from a dependency perspective. But with the container, that dependency management is taken care. Everything is going to be part of a predefined image. So you'll not get failure. Earlier, we used to say my application is working in development environment. It's not working in the QA environment. It is working in the QA environment. It is not working in the performance environment because of certain dependencies are not available, certain softwares are not available. With the containers, that is something taken care. That is the main advantage of having containers, right? And people use containers for better easy deployments and easy operational things. From a performance perspective, the application is application, whether it's going to be deployed in the your mission or it's going to be deployed on the container. Only thing is, if it's going to be there in the cloud, you may have to learn the additional cloud tools also. You may have to learn CloudWatch. You may have to learn the Azure monitoring tool, and all end of the day, it's everything a tool, right? Just need to know how to access it, how to look into it. But other than that, nothing, nothing challenge, nothing difficult in order to you to. So if you're going to spend 1 week or 2 weeks in a project where they use on AWS, you can easily go and understand all these things by yourself. So this session is going to be purely on the application performance engineering. See, auto scaling. Okay, somebody mentioned about auto scaling, right? Yes. See, that is a feature of cloud, right? Scalability. Whereas in on-prem, again, that is not a performance. That is a scalability aspect. That is the provisioning you additional service. If a CPU is high, memory is high, you're going to get another mission immediately, right? Whereas in on-prem, somebody has to monitor it, somebody has to go and physically attach it to the load balancer. But in the cloud, it is going to auto scale. That is the benefit of going to cloud, correct? But that is no way is going to improve your application performance. It is going to improve your scalability. For a user, they will not see failures. But if your application performance is not being optimized, you will end up paying more money to AWS. Say, for example, if everything is optimized, you just need 2 servers. Since it's not optimized, right? Your memory keeps on increasing. Your cloud might be giving you more and more servers, 3, 4, 5, 6. So which means you're going to pay more money, right? So this auto scaling, how it is going to work, how performance engineering is going to be more and more relevant to the cloud. Those things we'll anyway cover it in the introduction to the cloud. Yeah, and the recorded session is for after every day. You will get it. The next day you will get the recordings for your practice, and it will be there for you ever in the future also. Okay, so whoever registered will get the access to the recordings for every day, and then they'll also get the access to the Google Drive where you can download all these artifacts. Any questions related to the payment or registration, you can reach out to me. Okay, and anything you have questions related to the topics or the particular aspect of performance engineering, you can just WhatsApp me, or you can probably send a message in the group as well. I'll try to answer it.
Is MongoDB also included, like, or any other NoSQL database monitoring?
No SQL database is not part of the session. Again, we can include many things, but this is a structured syllabus what we have it. So MongoDB or Elastic is not part of the course.
Okay.
You might be using in your project, right? You might have this NoSQL databases, and just an additional information to you, right? If you have these CouchDB or MongoDB, just go to the MongoDB's portal, and they will be definitely having documentation around how to monitor the your MongoDB server, either the query times or your CPU or memory consumptions, number of calls to MongoDB, all these things. There are tools available through which you will be able to monitor it. And it's not, I have used it, it's not that complicated. I can just send you those links as well. Be it Elastic. See, Elastic, you can Elasticsearch, you can easily monitor it using Kibana. They are part of a single stack. InfluxDB has their own in the console. The Influx console, you can easily go and monitor it. You can look into the logs. And Mongo is also, I think they have some tools to get those query time or the infra statistics from the Mongo as well. Yeah, you just need to go through the documentation for a few days, and you can easily get it. And you can also go and check with your production team or with your architects, right? In production, what monitoring tool they are going to use it. And it's just that you need to, definitely they will have strategy for production, because in production they have to have the complete visibility. So they might have already decided what tools they are going to use it. You have to just extend it for your performance as well.
Okay, thank you.
Okay, so tomorrow we'll have a session the same time, guys. Yeah, if you have any questions on the payment or registration, you can reach out to Kumar sir. Anything specific to the course, you can ping me in WhatsApp, or you can send it in the group. Okay, we'll meet tomorrow again. Yeah, thanks guys for your time, for taking this attending this demo session. We'll meet tomorrow.
Thank you.
Yeah, thank you.
Thank you.